Again, Global Hack Week. I'm right back, coming to you with another awesome workshop. I hope y'all are excited. I know some folks are probably still getting through to the channel, so we're gonna go ahead and just wait for folks to drop into the chat. If you are here and you're watching, definitely yeah, let us know where you're coming from. Let us know what you're excited to learn about during Global Hack Week Data Week, because we are excited to teach you some cool stuff. Yeah, I see we've got some comments coming into the chat here. Hello again. Yes, if you Tuba, if you are looking for data related workshops, as you mentioned in the last workshop, this is definitely the place for you. So keep it locked in. Appreciate you. All right. So honestly, without any further ado, I just wanted to quickly introduce y'all to the team at LavinMQ, which is a message brokering service. So if that's not something you're familiar with, it's okay, because everything's going to be explained, and a lot of really cool things are going to happen during this workshop. So we do have Christina with us, and later we'll have Nior joining us as well. So without any further ado, I'll go ahead and put her up to the stage. Hi, Christina.
Hi. Hi. Nice to meet everybody. So fun to be here.
All right. Well, I'll leave y'all to it. I'll go ahead and disappear into the background. Later, y'all.
Awesome. Okay, so let's get started with sharing your screen. Not my screen. We have to have your screen for this one.
Can you see my screen, Christina? I think.
I think I can see it. I think we can see it.
Cool.
But I'm going to start you guys off. So I'm going to say hello, everybody. Super excited to be a part of this hackathon, and that you guys are here to listen to us talk a little bit about message queuing. Yeah, we have a lot of fun stuff to go through this session, and we'll try to keep it really simple and relaxed so everybody can benefit and learn something. And I guess we can get right into it. With the next slide, Nior.
Yep. Okay. Apparently this doesn't want to work. Oh, now it works.
Okay, here we have the agenda. Yeah, so we'll go through some background first on message queuing, and we're going to walk you through what message queuing is and when it can be used. Then we'll introduce the message broker LavinMQ and kind of go through some theory on the AMQP protocol and how LavinMQ uses the AMQP protocol. And after that, we'll introduce the challenges that we have provided for this hackathon. And lastly, we'll follow up with a small live code session, I guess you can call it. That is supposed to kind of help you get on track with installing the software that you need for these challenges and even solving the first challenge. But first, we'll begin with introducing ourselves. So my name is Christina. I am based in Stockholm, Sweden, and I'm a software engineer at a company called 84 Codes, where I also then work as the project lead for the LavinMQ project. And yeah, I've been at 84 Codes for about 3 years now. And before that, I studied a master's degree in computer science. So that's kind of my background. In my free time, I love to travel and see new places. I also really love to ski. In the top picture, you can see me and my colleagues on a ski tour when we were in northern Sweden last year. It was a really great tour. And in the bottom picture, that's just me on a mountain. I love to be outdoors and do outdoorsy activities. Yeah, so now you know a little bit about me. I'll pass the mic over to my colleague, and he can introduce himself too.
Hi again, everyone. So for me, like 3 years ago, I got accepted into the Major League Hacking Fellowship. It was an incredible period of learning for me, and it was so much fun because I got to meet some really, really amazing people. So it feels really good to be back in the community today and engage with you all. A bit about myself, I am Nior Clement. I work as a developer advocate on the 84 Codes team, and I've been in this role for over a year and a half now. My everyday work day, it's mostly about working with message queues, writing about them, and every now and then speaking about them as well. When I'm not working, I like to build things open source with Python, and the project I am most proud of is the Django REST CLI project. It has over 100 stars, and it's up there on my GitHub page. And my educational background is in software engineering. I have a bachelor's degree in software engineering from the American University of Nigeria in Yola. And today I am speaking to you all the way from Abuja in Nigeria, where I've lived all my life. And I work from home, so I am mostly indoors. That's a picture. The first frame is a picture of me working from home. I promise you, I am not always this disorganized. And the second frame is a picture of me trying out go-karting for the first time. And that's why I was looking that nervous or sad, I think. I don't know, one of those. And like Christina has hinted, today we're going to talk to you about message queuing with LavinMQ. But before we jump right into it, I would like to say a few things about 84 Codes. Now, 84 Codes is the group of people behind the more well-known platform CloudMQP, where we have been providing RabbitMQ as a service for the past 12 years now. But recently at 84 Codes, we launched our own message broker, LavinMQ. And that's what we're here to talk to you about today. And just to clarify at the beginning, I'm going to be using the terms message broker and message queues interchangeably throughout this presentation. Before we start, I'd like to do a very, very quick survey. Now, if you've worked with a message queue like RabbitMQ in the past, I'd like you to say yes in the chat box. If you're on Twitch or Twitter, just type yes. And if you haven't worked with a message queue, also just say no. Don't be shy, just say no. It just gives us a sense of who we have in the audience today and how to approach the talk in general. I'll give you like 5 to 10 or 15 seconds to do that. We'll wait. Okay, I see someone saying I've heard of the queue data structure, but never heard of message queuing. Guessing it's related to the queue data structure. I see no, 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 no. Okay, I see a couple of persons that haven't worked with message queue, and some say they've heard of the queue data structure, but not message queue in itself, which is totally fine because in this talk, we're not just going to jump right straight into LavinMQ. We're going to start from the very, very beginning. What are message queues? Now, I personally like stories and analogies. I don't have a story for you today, but I have an analogy that I believe would help you understand message queues. And that's a database. Now, I believe it's a very common technology that we're all familiar with. And database is what we use for data persistence. You think of technologies like Postgres or MongoDB. Now, like databases, message queues also perform some storage function. But this raises the question, if you already have databases for data persistence, why then do you need another technology like message queues for data persistence as well? Now, to answer this question, just think of databases and message queues in terms of warehouses and post offices. Now, personally, to me, I feel like databases are just like warehouses. They are designed to hold a lot of different things, most times over a long period of time. Now, with warehouses, you could put items into a warehouse and then take items out, but not necessarily fast or instantly. Now, message queues, on the other hand, are like post offices, where letters and packages stop briefly on their way to being delivered. They don't stay there for long. They just sorted and sent off to where they need to go to. Now, let's put everything together, databases and message queues. Now, databases are primarily designed for scenarios where you need to persist and manage some state over a long period of time. Now, in contrast, message queues, you'd want to use a message queue for data that you do not want to keep around for very long. So basically, a message queue holds an information just long enough to send it to the next stop. Now, if we're thinking of message queues from this perspective of post offices, you would begin to appreciate the fact that message queues are simply just technologies that allow data to flow from a source system to the message queue, and then from the message queue to the destination system. Now, in this tech domain, you'd hear message queues often referred to as middlewares because literally they're just middlewares. They sit between systems. Again, just to clarify, looking at message queues from this perspective of having it as this medium of data flow is not the only way of looking at message queues. It's not the only perspective, but we're trying to simplify things at this point. And besides, it's sufficient to help you get started with message queues. So let's double down on that perspective. There are some formal terms you need to be aware of in the message queuing parlance. So the source system that generates data and sends it to the message queue is called the producer. The data sent to the message queue is called a message. And then the receiving application is called a consumer. Now, an important thing I need you to note, and someone mentioned that he has heard or she has heard of the queue data structure. So message queues would a typical queuing system would arrange the messages it receives in the exact order they arrive, such that the first message to enter the queue would be the first message to leave the queue. And in fact, this is where the name is driven from, the queue data structure. So that person is right, basically. And now that we understand the core essence of message queues, let's explore some of their practical use cases. We've already seen how message queuing systems allow data to flow from a producer down to a consumer, right? This inherent nature of message queues makes them perfect for communication between systems in a microservice architecture. Now you're probably wondering, what is the microservice architecture, right? I'm going to start again with something that I believe you're all familiar with, the monolithic architecture. A monolith application is characterized by the entire code base being inside one application. Now, usually this is a great approach for smaller projects. And in fact, many new applications you'd work on start out as a monolith. This is because on a smaller scale, monoliths are easier, faster to develop, easier to test, and easier to develop as well, to deploy as well. However, when the monolith starts to get really, really large, it grows, begin to notice some problems with this architecture. For example, a large monolithic application makes development a bit more complex, and it's generally a bit harder to onboard new people to a very huge monolithic code base because they have to learn a lot and start to work with it. Secondly, a small change to a monolithic application would usually require a redeployment of the entire monolith. Just to help you understand what I'm trying to say here, let's consider an example. Imagine you're working on an e-commerce application, right? And you've decided, oh, you want to add an extra field to the product table. Typically, you persist products in your databases, and you just want to add an extra field to that product table. Naturally, when you add a field, you would want that change reflected in the data you send to the front end, right? That is a super trivial change. You're just adding a field, and then you're sending that new data. You're sending the product data with that new field. But if you're working with a monolith, a change as trivial as that would require you rebuilding the entire monolith and redeploying it. Now, a third problem with a monolith is if there is an error in one module, it could affect the entire application. Again, consider an example. Let's say you have a monolith with an authentication component and a bunch of other components. And let's say the authentication component has a memory leak related bug, right? Because you would host a monolith on one hardware, the bug in that authentication component would indirectly affect all the other components because they are hosted on that same hardware with that memory leak bug. Now, these are just some of the problems you face with a monolith, really. It's not even like a comprehensive catalog of all the problems you could face when working with a very huge monolithic code base. So we've seen the problems. What is the way forward? Yes, this is the way forward. So many times the solution to these problems is to break up your monolithic application into smaller applications called microservices, with each service focusing on a single area of responsibility. And this approach has a couple of benefits. First of all, with microservices, it is easier to implement changes to your code and also a bit easier to onboard new people because it's a relatively small code base. With microservices, there's fault isolation as well. And what this means is if, for example, one service is faulty, the bug will be isolated to just that service. This makes your application more reliable compared to a monolith where a single component error could take the entire application down. There's also the opportunity to diversify the technology stack from service to service, which helps you optimize your services for their purposes. So, for example, a performance critical service has a chance to make certain performance trade-offs without putting limits to the rest of the services. And naturally, scaling becomes a lot more easier because you can just scale one of your services instead of scaling the entire application. And this would save a lot of resources. Okay, now we know what microservices are, what message queues are, we know what microservices are, but let's not forget the main point we're trying to make. The fact that you can use message queues between services for communication. So let's cycle back to that. But before we delve into that, I'd also like to mention that using message queuing is not the only way to get services to talk to each other in a distributed architecture. There's one other common approach. There is the synchronous communication where you don't place a message queue between the services, you allow them to talk to each other directly via, let's say, REST API call, for example. So imagine if you have two services, service A, service B, and you want them to communicate synchronously. Service A would send, let's say, an API call directly to service B, and it will wait for service B to handle this request. Service B would then handle this request and send the response back to service A, and then service A could then continue with whatever it needs to carry on with. What I consider one of the biggest flaws of this approach is that the services here are tightly coupled and they're just super dependent on each other. And I consider this a problem because it undermines one of the core principles that a distributed architecture should adhere to: autonomy. The services shouldn't be super dependent on each other. And that's because if, for example, service B is unavailable and service A needs to talk to service B, then that would affect how service A responds because service B is unavailable. Now, the second approach is with message queuing, which falls under the category of asynchronous communication. Now, in this pattern, instead of having the services talk to each other directly, you place a message queue in between them. So if you have pursuing our example again, you have service A and service B. Service A will send messages to the broker, and instead of waiting for service B, it will receive a super quick acknowledgement from the broker. Service A can then carry on doing what it was doing while service B fetches the message from the queue and handles it. This asynchronous approach between using message queues between the services is more decoupled, where the services don't have to be online at the same time to be able to talk to each other. Okay, to illustrate this notion of using message queues as a medium of communication between services, let's look at an example of an e-commerce application. Now, if you're building your e-commerce application the microservice way, you would typically have a bunch of services. For example, one service for handling inventory, one service for registering orders, and a service for making payments, and a bunch of other services, basically. Now, when a customer goes to buy an item on your platform, they will fill in at checkout, they will fill in their information and they will click pay. Once they click pay, the checkout service will send the request to the payment service, and the payment service will start to handle the request. However, it needs to connect to the bank, and we cannot predict for sure how long it will take the bank to process the request because it's an external API. And this means the checkout service and ultimately the user is left waiting until the payment is being processed. But sooner or later, of course, the payment service and by extension, the bank will process the payment and send the confirmation. But the thing here is during this payment processing, the customer will be waiting for the screen to show confirmation of the payments. This is mostly because your services are working synchronously, and this pretty bad user experience, especially if it takes the payment service really long to process the payments. Now, this user experience even gets worse if you start getting a lot of those requests, because then you'd have the payment service trying to process multiple payments at the same time. With the message queue, however, you're able to reduce this waiting time significantly. And I say this because with message queuing or asynchronous communication in the picture in general, the checkout service will send a message to the broker and return a response instantly to the user. This response would be a promise that their order has been placed and that the receipt will be sent to them soon. So yeah, that was an example of how message queuing can be used for communication between services. And now that we understand what message queues are and when to use them, let's get a sense of how messages flow from a producer to a message queue and then to a consumer. I will do that in just a minute or two. Now, producers and consumers would usually communicate with a broker via some messaging protocol. Now, to do that, the producer or consumer would leverage some client library that implements the protocol that the broker supports. Most message brokers commonly implement at least one of these protocols: AMQP, MQTT, and STOMP. Now, LavinMQ, the message broker we will be focusing on in this workshop, implements the AMQP protocol. Yeah, and that's that for how message queues work at a very high level. I will now hand it over to Christina, who will tell you more about LavinMQ and how it implements the AMQP protocol. The stage is yours.
Awesome. Thank you so much. Can we promote my screen? Yeah, awesome. You guys are on top of it. That's great. Yeah, so thank you, Nior. Now you guys have gotten like an overview of what message queuing is and what it can be used for. And now I'm going to go into a bit more detail on the actual software. And I'm going to be talking about LavinMQ, which is, like we've said a couple of times now, our message broker that we've developed in-house at 84Codes. It's an open source project, so you can find it on GitHub, and you could follow along in the development there if you're interested in message queuing, or if you need information throughout the hackathon week about kind of how to get started with installing stuff and stuff like that. You can find a lot of like information compiled in the README file of that project on GitHub. Yeah, I will kind of get you guys started today in this workshop, but if you ever want to go back to some info, you can find a lot of stuff there. Yeah, but LavinMQ is a message broker, but what it makes it so special is that it aims to have a very low memory footprint, and it kind of uses the memory resources of a machine in a more efficient way than other brokers on the market that we see today. And on a usage level, LavinMQ is very similar to other AMQP brokers. Examples could be like RabbitMQ, but it's fundamentally different in its architecture and how it's been developed. And I'll tell you a little bit about that. And it's like this. So instead of caching messages in the process memory of the program, like other traditional message brokers do, we let the operating system handle that caching, and then let the operating system write all of the messages down to disk. And this is actually much faster because we do it in a way that lets us avoid making a lot of like expensive read and write syscalls to the kernel. And that gives us a significant performance boost. And that's kind of one of the main selling points about LavinMQ, is that you can push over 1 million messages per second and get some really like impressive throughput performance. And other than being very effective and fast, it's also a super lightweight software. The code base is pretty small and it needs minimal configuration to get up and running. And yeah, it's pretty easy to use as a beginner, which we think is great. And yeah, to explain how it works on a usage level, I want to go through the protocol that it uses, AMQP, that Nior mentioned, and kind of touch on the basics of how an AMQP message broker works. So yeah, AMQP, it stands for Advanced Message Queuing Protocol. And yeah, it's used in LavinMQ, can also be found in other popular alternatives. Like I mentioned, LavinMQ, also ActiveMQ, if you guys have heard about that. And with an AMQP message broker, you typically have, like Nior said, a publishing service that publishes messages to the message broker. And this green little dot is supposed to be a message. I just want to be clear on that so it's not confusing. Yeah, but to publish a message, the publisher is going to open a connection to the message broker. And in AMQP, a connection is like a virtual link between your application and the message broker, which opens a line of communication between the two. And an application typically wants to interact pretty frequently with the message broker, like sending a lot of messages, and connections can be pretty expensive to open and close. So instead of just opening and closing connections all the time, you can reuse a connection and open something called a channel inside of that AMQP connection. And channels allow for connection multiplexing. And this means that you can have many smaller connections on one large physical connection. And you can think of channels as like lightweight pathways within this connection. Each channel is capable of carrying its own stream of messages. And by using channels, you can reuse a connection and avoid opening and closing connections between the apps and the message broker. So that's pretty good for saving your resources. Yeah, so once you have a connection established and you want to send a message from your producer to a queue in LavinMQ, you're going to open a channel and send a message on that channel. And so when you send a message into LavinMQ, actually you don't publish a message directly to a queue. Instead, you're going to publish them to an exchange. And an exchange is a routing mechanism within the message broker that routes your message to the correct queue. And just to kind of show you how that works, I have an example here. The exchange uses something called bindings and something called routing keys to determine what queue it should send a message to. So a message is going to come in and it's going to have a routing key attribute. And in this example, that attribute is called Q1. And now this exchange is going to look at those bindings that it has and see if there is a binding to a queue with a routing key Q1, and then it's going to send that message into that queue. And yeah, this is like the most simple type of exchange. There are other types of exchanges that allow for more advanced routing techniques, but I won't go too deep into that in this workshop, just kind of keep it simple. And yeah, we have great documentation of how different exchanges work on our website. So if you would like to try out different exchange types for your solution, I recommend to go follow some of our tutorials on cloudamqp.com or read the documentation on lavinmq.com, or ask us, we can help you. Okay, so continuing with our base example here, the publishing app is going to send a message with a routing key Q1, and that message is then going to be routed by that exchange into Q1. And then that message is going to stay in that queue, however long it takes, until a consumer comes and subscribes to that queue and consumes the message. So the message is going to be removed from that queue only once it has been consumed by the consumer. And yeah, that is basically the message flow of an AMQP message broker. And now I think I'll take a short break from talking and let Nior introduce the hackathon challenges that we have provided. And I will be back in the end to show you a live example of how to install LavinMQ locally or run it with CloudMQP. I'll try to show you the two. And then I'll show you how to set up a publishing and a consuming app. But yeah, over to you, Nior.
No, you can just leave your screen, I think. Okay.
Yes, let's see here
yes.
if I can get the stuff up. Are you seeing
it?
Yes.
Yes.
Awesome. Okay, great.
Right. Thank you for that introduction to LavinMQ. And I'm just going to say that this challenges in general, the whole idea is to allow you apply the theoretical concepts you've learned about LavinMQ, exchanges, queues, and yeah, just be more hands-on. And we have 3 sets of challenges for you. The first one is the registration challenge. It's super simple, really. There's just one task for you to work on in that challenge. and it's create a free LavinMQ instance on Cloud MQP. And the second challenge is probably the most interesting for me. Not sure about you. And we have like some set of coding related tasks that are built around message queuing. And the third one is just a bonus challenge, really. It's totally optional. And even though we encourage you to work on it, you really don't have to. So now I'll just go over each of the challenges one after the other. Coding challenges, like I said, the whole idea is apply the message queuing concept you've learned. And we have three different tasks in that category for you. What you have to know is that these three tasks are connected and layered. So it is super important that you solve them in sequential order. You work on the first challenge, then you proceed to the second one, then you move on to to the last one. Uh, an overview of what you're going to build. Christina, could you open the overview and click on the image?
Absolutely. Let's
Yeah,
see. Is it the overview here?
you
And this is, yeah.
just click on the image.
Great.
Yeah. So what would you be building? You're going to build a simulation of a notification system. And I say a simulation here because you're not going to be sending out real notifications. You're going to just be logging things to the console. And your notification system is supposed to capture events from three Slack channels. So you have a producer that will capture these events. It will then publish these events to three different queues on LavinMQ. And then you're going to create three consumers that will consume these events from these three different queues. Or that's the overview. So if you follow the challenges from the first one to the last one, you should build something that looks like this. Not visually, of course, but yeah, you get the point. You can close that, Christina, and you can close it and go back to Notion, Christina. Okay. Yeah, so in the first one, the first task in this category is just think of this as the hello world of messaging, really. So what we want you to achieve in that first challenge is just to create like a producer that sends messages to LavinMQ, and then a consumer that would consume messages from LavinMQ. Thankfully, right after this overview, Christina will walk you through how to create your very first producer and consumer with LavinMQ. Just right after completing that, the second challenge is about using exchanges, queues, and bindings. It's basically about understanding this whole concept and applying this whole concept of message routing in LavinMQ. Then the last challenge, which is challenge three, running three consumers. Up until that point, you would just be working with a single consumer. So in that third challenge, the idea is to get you to be able to work with multiple consumers that will consume messages from multiple queues, separate queues. Um, One last comment about the coding task. If you haven't worked with message queues at all, they might seem intimidating at first, or maybe it's just in my head. I don't know, but I think they might seem intimidating at first. Uh, they're not really that hard if you try to follow the tutorials, because for each challenge we have a very comprehensive tutorial that should help you work on the challenge. So if you go through the tutorial first before attempting the challenges themselves, they might it might turn out to be a lot easier than you think, or harder than they're not. Yeah, and the last one, bonus challenge. Like I said, you don't really have to work on this. But if after this whole hackathon, you're excited about message queuing or LavinMQ, and you just and you want to write about it or blog about it, please by all means do. And when you do, just drop it in the LavinMQ Slack. But then if you don't want to write, you can just tweet about LavinMQ or a short post on LinkedIn and just tag LavinMQ. We have a LavinMQ account on Twitter and LinkedIn as well. Please, Christina, could you go back to the open the registration challenge for me, or quickly just mention? Yes, just open it a bit. Yeah. Yeah, like I said, you're supposed to create like a LavinMQ instance on Cloud MQP for the registration challenge. Uh, Christina will talk about this a bit more. There are two ways you can work with LavinMQ. You can either install it locally on your machine, or you could just work with it on the cloud, on CloudMQP. Now, if you would rather install LavinMQ on your computer and work with it locally, then you really don't have to create an instance on CloudMQP. So yeah, you can skip the registration challenge if you want. But one thing we strongly recommend you do is you join the LavinMQ Slack, and yeah, then join the Global Hack Week channel and ask all your questions related to the hackathon there. Of course, you could ask us questions on Discord, but the good side of asking on Slack is if you ask questions that I can't answer or Christina can't, then you have other engineers there that will be able to help you out. Yeah, I think I would stop right here, Christina, and you can continue.
Okay, so awesome. What do we have next then? Let's get started with some code. Right, so now I'm going off script. So hopefully I won't ramble through this too much, but yeah, I have this instructions file here to kind of guide me through this code session. And we're going to begin with installing LavinMQ from source. Then I'll show you, just because I'm on a Mac and it's easy for me to show you the commands, I'll just show you what you can do to install it with Homebrew as well. And then I'll show you how to run LavinMQ with CloudMQP. This is going to be the easiest one, and it's free, so no issues there. And after that, after we have our service live and we're running LavinMQ, we can continue with creating a publisher app, and we can build a consumer app and kind of see that. Oh, yeah, zoom in, of course, absolutely. Yes, okay, is that good? Maybe?
Yeah.
You'll have to let me know otherwise. Yeah, then we'll build the consumer app, see how the message flow goes, and yeah, we'll just see how LavinMQ reacts with these two apps, publishing and consuming from them. Okay, so I guess we can start with looking at installing LavinMQ. So the first thing with installing LavinMQ from source is that you are going to have to install the language Crystal. And that is the easiest way to do that is to go to Crystal's website, crystallang.org, and follow the installation instructions here. You have a range of different operating systems to choose from. I'm going to choose the Mac one, and I use Homebrew, so I'm just going to copy that. And for me, it's just going to tell me that I already have this installed. But for you guys, it's going to install. But yeah, I'm not going to reinstall stuff because then it probably breaks. And yeah, we don't have time for that. But yeah, so you begin with installing Crystal, and then you're going to want to clone the GitHub repository. And so you're just going to copy it however you want to, and then you're going to do git clone, and you clone LavinMQ into your repository of choice. So now you should see that you have LavinMQ here, and you can navigate into that and see how that looks. You won't be working too much in this folder, but you have to be there to build the project. And I'm going to build it with make. And since it's a Crystal project, it has something that's called shards, which is it's a dependency manager, you can call it, which kind of keeps track of your dependencies. And here you see LavinMQ has a few of dependencies. So it's just installing all of those, and then it's running Crystal build. So it's going to build the project for you. And yeah, this usually takes a couple of seconds. So, but now it's finished, and I should be able to check the version here. And yeah, we see we got the latest version, 1.2.11. And yeah, that's pretty easy. Then let's see. to start LavinMQ, then you have to run LavinMQ, and then you use the flag capital D, and you give it the repository or the folder that you want it to work on. So I'm choosing varlib LavinMQ. And then it just starts like this. I'm able to navigate into the management interface on this localhost port. Let's see if we can find the browser. It's like this. And yeah, this is what it looks like. You're going to be able to see a couple of metrics, how many queued messages you have. This is an overview, so this is for all of your queues, but you can go into more detail here. I have a test queue that I was working on before this, so I'm just going to delete that. But yeah, here you get an overview of your queues, your exchanges, connections, channels. Yeah, you can see a lot of things. This is a great tool for you guys when you're working on the challenges. And yeah, like I said, you can just do brew install LavinMQ with Homebrew as well. If you use Homebrew, it's going to tell you that, or it's going to tell me that I already have LavinMQ, but for you, it could install it. And then you can actually, with brew services, you can start it as a background service. So you can just go brew services, start LavinMQ, and it's going to run in the background. But I want the logs in. Yes.
Can you zoom the terminal a bit just so it's a bit more?
Absolutely.
Yeah. Cool.
Okay.
Cool.
See better now? Okay.
Yeah.
Yeah. So I'm going to use I'm not going to use Homebrew because I want to see the logs actively.
Yeah.
And yeah, okay, yeah, running LavinMQ on Cloud AMQP. So this is the simplest step of it all. You go to Cloud AMQP. Okay, I'm just going to log out so you can get the full experience of logging in. And you're going to want to register or sign in with an account. I have a Google account. I'm going to use my personal account here. And this is what the console kind of looks like. And you just click create new instance. And as you can tell, I have no credit card information or billing information, so it's warning me here. But this means that I can only create the free instances. And important here is that you choose the LavinMQ backend for your service, which is going to be the Loyal Lemming. The other one is RabbitMQ. So choose LavinMQ for this challenge, and then you're going to pick a name. I'm just going to call it Christina, and I'm going to select a region, and you can just select whatever region that you are comfortable with. And then I review it, and I create the instance. And it's going to spin up almost instantly because it's a shared instance. So the host is like a multi-tenant host. But yeah, here you can then click on that instance name, and you can get some more information on your instance. And the important stuff here can be found in the AMQP details. So here you have the URL that you might connect to your applications. So you just copy that by clicking this button, and you can use that URL to connect to your applications. And you also have some information on the user and the password here. And then you also get access to the LavinMQ manager, or the management interface, as I like to call it here, via this green button. And you get the same view as you would if you started it locally. And yeah, that's basically how easy it is to run LavinMQ locally and on Cloud AMQP. So let's get into creating our publisher app. And yeah, since this is, we are coding in Crystal today. So I'm going to create a publisher app here in Crystal. And since it's a Crystal application, I have shards, like I told you about earlier. And I am going to include the AMQP client library here for me to be able to use that to do AMQP stuff with my app. And this is our own. You can see that it comes from the Cloud AMQP GitHub repository. but there are like a lot of AMQP clients out there, and there are one for every language that you can imagine. So if you want to go with Python or Rust, there's going to be a client for you. I'm choosing this one because I really like this one. We have also written clients in Ruby and in JavaScript, which are more popular alternatives, I guess. But Crystal is it's an undiscovered language. So I take every chance I get to kind of get it out there. It's basically the same syntax as Ruby, but it's a compiled language. So it's a little bit more performant, and we like that. So yeah. Okay, so what do we want to do now? We're going to create our publisher app, and I'm going to start with including the library, the AMQP client library, and in Crystal that is require. AMQP client, like this. Oh yeah, and GitHub Copilot is going to be with us today. Hopefully it doesn't bother us too much. But yeah, then I can just access the AMQP client namespace through that library, and I'm going to call a method start, which is going to initiate a connection to the LavinMQ server. And as you see here, Copilot is wanting me to enter an address, and here it's giving me the local host. And actually, localhost with this port is the default for this library, so I don't have to put in anything. I can just start with writing my block here. And if you're familiar with Ruby, this looks normal, and if you're not, this looks less normal. What this is it's basically you're passing a block of code to the start method. I won't go too deep into syntax stuff today. And then I'm going to use that client argument, and I am going to create a channel like I taught you to do earlier. And I'm going to initiate another block with that channel. And so now we have started a connection to the AMQP server, which is LavinMQ in this case, and we have a client channel that's opened. So now we can start doing things with queues and sending messages. So I'm going to initiate a queue variable here, and on that channel, I'm going to declare a queue, and I'm going to call it test. And then I'm going to create a message, which we can say is hello world. Like this. Great. And now I'm going to want to publish that message on this channel. So I'm going to take the queue and I'm going to write publish, and I'm going to publish that message. And now it looks like I'm publishing a message directly to a queue, which I told you guys earlier that you don't do that in AMQP. But since I'm not specifying anything, the default of this publish message, okay, I have to actually publish, spell that right. The default of this publish message is going to route it to the default exchange, which is a direct exchange. So it's just gonna like do the hard stuff for me, which is really convenient and which is nice when you're using these types of clients. And yeah, and then I'll just have some sort of print line, and I'm gonna say sent message. So we should be able to see that when we run. All right, I have to. Yeah, and so we're supposed to see that message when we run this, and this publisher is supposed to then publish a message to the queue test. Okay, so let's see if this works. Hopefully it does. So I will create a new one here, navigate to presentation demo, and then I'll just do Crystal run, and I think we called it just publisher dot crystal, like this. And yeah, this is going to fail because I saw that we have not started LavinMQ. And yeah, you see it fails because it's connection refused because the host is not online. So let's see if we can start LavinMQ. So now that's started, and now this should publish better. Yeah, and you can see here the publisher sends hello world. And you can see in the LavinMQ log as well that there has been a connection established for the guest user here, and there has been a connection disconnected for the user. So it's been into this server here and done something. And now we should be able to also see that in the local host. Let's see if we can go to localhost here. We should be able to see that the message rates went up, and you should be able to find your queue here. And you can see that you have one ready message in that queue. And just to see, you can also get the messages from that queue. So if you just press get here, you can get that one message, and you can see that it's the correct one. It's been routed correctly, and it's been through the default exchange. And you can see here that the payload is what it should be. So I would say that our publishing application works pretty well. So let's get into creating the consumer. And I'll just do the exact same thing here. I'll start with requiring the AMQP client like this. And I will start again with establishing a connection. Client.start. And like this. So basically the shell of these two apps are basically identical. And then I have the client.channel. So I'm opening a channel like this. So yeah, we start out the same, but then yeah, continue the same. I'll just initialize the queue, and so that we can find that queue that we have established in the publisher. And then I'm going to subscribe to that queue on this channel. So that means that when there are messages on that queue and this subscribe block is run, they're going to consume those messages. And then you can do whatever you want with that message in your own solutions, but I'm just gonna, print the message out. Yeah, we'll start with this and we'll see what happens. Let's just see where the terminal is. Great, so now we have up here, we have LavinMQ. In the middle, we have the publisher. And here, I'm just gonna navigate over to presentation demo, and I'm gonna run the sudo crystal run the consumer.crystal. Let's see how that, okay, right. Always do this. So yeah, have a little bit more expressive variables today so you guys understand what I'm doing. But yeah, let's see. Right, and so now you can see here there was another connection established in LavinMQ. And we should be able to see here that it has consumed messages. There are 0 messages in the queue now. And yeah, so that works. However, I'm a little bit surprised that it didn't print anything, but I want to try something here. So I'm going to define the block as true, or that attribute of, or the argument of the subscribe method has a block argument that you can set to true. And I think that that's going to like keep this subscribe alive so that this client doesn't execute and finish, which means that it will wait for like incoming messages on that queue. So I'll just have like a puts line here and say waiting for messages. Great. Okay, and now I'll just try to start that. So that is running. And you can see then, yeah, that we get this waiting for messages and that it doesn't execute. And let's see if we run this publisher. And yeah, exactly. And then we see this received beautiful message here that's really hard to read. And let's make it a little bit easier to read. You should use the body instead. Like this. And let's just restart this consumer. And see. So yeah, now it's waiting for messages. And if I send this, we get received hello world. And yeah, you should be able to also find that your consumer is connected here on your connections. And yeah, that's basically how that's going to work. You're going to be able to publish stuff however you want. And then your consumer is going to be able to consume from that queue. Yeah, I guess that's what I have for today and in these instructions. I hope that you were able to follow along. And yeah, Nior, do you know anything that I've missed or anything that I should?
Did we point out that they could also install on Linux with apt?
Oh yeah, sure. Right.
Okay.
You can absolutely install this with apt-get install LavinMQ.
Yeah.
So yeah, that's absolutely available.
Yeah.
Yeah, but I think that concludes the workshop. And yeah, we are available for the whole week for questions and stuff like that. So we're really excited to connect with you guys and see your solutions and yeah, get coding, I guess.
Yeah.
Awesome. Thank you so much, y'all. There is an issue with my camera, so I'm gonna just like be here on audio. But thank you so much, folks, for all of the amazing information that you provided. Obviously, we can continue to ask questions via Discord. So go ahead and head over to the Discord channel. It's ask-LavinMQ, and all of the awesome challenges that you can participate in are going to be at hackp.ac/GHW data 24-LavinMQ, and we'll have all that information in channel for you as well. Thank you so much again, Christina and Yor, and yeah, enjoy the rest of Global Hack Week, y'all.
Thank you so much for having us.
Thank you for having us. Yeah.